that delivers different tracks for different programming languages, and one of them is Dart. And today we want to work in Dart. And as you see, I already solved some of the problems here, like hello world, resist color, and so on and so forth. And today I want to take another look into the GigaSecond after we have solved yesterday the phone number. Okay, so the GigaSecond, what happens here? Excersim has a big benefit, and the benefit is that we can download exactly the whole project, and then we can run the tests locally on our machine with our environment. So people who are wanting to use JetBrains, for example, can do that. People like me, I will use today Visual Studio Code, can use that either. So what you have to do is you have to make the begin walkthrough, and then you can choose your OS. And whatever you choose, for example Mac, you can use Homebrew, a package manager. You install with Brew the Excersim CLI, and with that Homebrew Excersim CLI you are able to download the different exercises. And I will do that with you today together. So we can go in our terminal, like so, and then we can say Excersim. If I installed it correctly and I press enter, it's a tough word, so Sysim, so this time you can see there happens something. And if I can I can just execute that code here that we get from this download section, and you see it downloads some files into that GigaSecond here. And now what we can do, we can go into our Visual Studio Code, and I think I will make my picture a bit smaller, then it's easier to follow. Voila, good. Then inside of Visual Studio Code, we open up the project that we downloaded seconds ago. So for that, I go here. Guys, if I'm speaking too fast or if I'm doing anything too fast, just write it in the comments. I'm a bit nervous today, so it's my second time. And yesterday I talked under half hour with myself. So yeah, so I open up the project, GigaSeconds in that case. And what you can see now is we get a pretty normal standard Dart project. And the benefit of the Excersim is they are pretty normal created. So it's just a project where we have a lib file that contains where we have to write our code. And we have the test where we get all the tests that we have to make green at the end. And then let's get started. So what we can do is we can open up the integrated terminal, and it's open up down here. And now we can run, for example, pub.get, because we need to solve all the packages that are coming with. And if we take a look into the pub/spec YAML, there is exactly one dev dependency with testing and the SDK for Dart between 2 and 3. And I think the current version of Dart should be 2.7. And yeah, with that we can now run the tests. Pub run test. And if everything works well, we should get a lot of errors, or more specific, exactly one error. The thing is, inside of our test file, we can see there are some errors. So for example, there is the add function that we should call. And this add function seems to be missed. And if we take a look here, we import the GigaSecond.dart, which is that one. And what we have to do now is inside of this class, we have to add the new function. So for example, add, and if we take a look back into the GigaSecond, we take over a birth date, which is a date, UTC. Okay, so that should be a date time, birth date. And we have to do something with it. And do we return something? We return a date time, if I see that correctly. That seems weird. Where comes this add from? Okay, but the good thing is for such cases, if we have questions, we can just jump into back into the GigaSecond, and there we see also some examples and also some more information about it. So we can read the introduction. So given a moment, determine the moment that would be after a GigaSecond has passed, which is 10 power 9 seconds. For detailed info about Dart track, okay, we have done that already. And we get here a reference to the original task where it comes from. So, okay. But somehow that doesn't help me with that add here. That looks a bit weird. Isn't defined. Try import library that defines add. Add 1 gigasecond to the input. Okay, so it seems that we don't want to have a class here in GigaSecond. We want more to have just add here. Convert to an asynchronous function. Why? That is not useful. So let's see. Is that now green inside of the test? I have to save it first. And now, do we get better? No. Can't be assigned to a variable type datetime. Try changing the type of the variable or casting right hand to the datetime. It says me that this one is now dead, but of course we have to return datetime. So now it should be better. Okay, but it doesn't return anything. That is true, so we return null for now. Okay, and if I run now in the console the pub run test, we should get still an error message, but at least the add function will work now. So what do we get here? We have here date only specification of time. Okay, so we return null, but it wants to have a date time. Okay, so what is happening with that add? We have to add 1 gigasecond to the input, date time only specified of time. Okay, we expect an expected date, which is 30 years later. Interesting. So what do we actually have to do? It seems that we are 32 years later in January. Okay. So what is a gigasecond? It is 1 gigasecond seems to be 10 power 9. So I think that it would be beneficial if we import the math library here, which I can do. Import math. No, where is it? Dart math. Yep, here we go. Why is it red? Because it's not used. Okay, yeah. But I want to use the math library to receive that POW. The question here is now, if I add a datetime or create a datetime, I thought I can just say here's seconds for it. So if I have a datetime that I want to create, GigaSecond datetime, make that small. And what is it? I can add here some dates, that is fine. I think that should work. But what I actually want is, I want to have a look. Okay, 2 ISO is after, but I thought I can just use the different, I thought I can just enter the year that I have. How does the datetime actually work? So let's go to the API. We jump here, Dart, datetime, and have a look how the class of datetime looks actually. Okay, so we have the datetime now, which gives us the today now state. We can parse a date, of course, and we can create it with a constructor UTC. Interesting. Okay. But what actually want we to achieve? We want to add this 10 power 9 of seconds into our datetime. To be frank, I would think that we have a duration, and this duration has seconds, right? And it's 10 power 9. So what we can do is say math.pow. Yeah, pow. Now we take x and the exponent, so it is 10 and 9. And this would be our duration. So this is our gigasecond duration, I assume. Does that work? Returns x to the power of if x is an int and exponent is a not negative. Okay. But why is it getting red? Here. Because it is a number, not an integer. and the duration needs an integer. And I assume that the GigaSecond is way too big for an integer in Dart. But we can try that still. Can say toInt. Let's see what we get. We'll make that a variable. Or even better, just int. And now we can use this duration. And I thought if I have a date time like birth date, I can just add the duration. And the duration would be GigaSecond duration. So, does it work? Still red. Why? Can't be assigned to type duration. Because the duration of seconds is red. Because that is, yeah, sure. Duration. Okay, so now we get the duration and we add this. And now we get a new date time back that we want to return. Let's see what we get. Actually it worked. That was quicker than I thought. All right, so this is done. We put that on false. It's the next test in our test class. And with that, we are running a bit more test driven. So we solve a test, we go back to our code, solve the issue, and going back to the test again. Let's see, the second test is also passed. Okay, looks fair enough. Another test. Also passed. Hey, that's pretty decent, I think. Okay, and with that, I think I solved already the problem. So that was way quicker than I thought. With the problem yesterday, I needed much more time. Cool. All right, so with that, all the tests has passed. I don't see any problems with that at the moment. So what I can do is to make it more smaller and compact, I can just take this duration where I say it to int and everything. I can just take that, put it down here. And now instead of returning everything, I can also say we just use the fat arrow just to make it smaller. So, and I think with that, everything is readable and easy to understand. Do I see a disadvantage of that? Do you see any disadvantages of that? I think it should be fairly easy. The only problem that I have at the moment is that the add function looks like a terrible idea in my case. I don't think that add is a really good name for a variable, or a bit more better for the method itself. It would be more add GigaSecond or something. But I think that should solve the issue here. Yeah, so with that, if we solved an issue in Excersim, we can go back to the page. And down here we have the submit page. And if I click now on copy and put that here, you can see down here that we get a lot of info, but we want just to make Excersim submit, and then we target the GigaSecond Dart. And with that, now we can see our solution. If I open that, just a second. So if I refresh here, you can see immediately, that is our solution. And now we can say we complete our solution because we are finished. Yeah, right. We can request mentor feedback. So if you don't know Excersim, you have the option down here to ask or to go to a mentored mode. I can try that for now. And if you are in a mentored mode, you always submit your information to a mentor, and he will read it and give you feedback for that stuff. So that is really useful, especially if you're new to a track or if you want to learn a new programming language, that you can work together with some people who have more experience. Okay, but for me, I will switch back to the non-mentored mode if possible. How? Or maybe it is not possible anymore. I can't leave track, switch to practice mode. Yep, here we go. So don't want to give all the mentors every work that I have. And now, okay, unfortunately now the mentorship is, the request was started, but I canceled that for now. But you can request this mentor feedback, and then someone like me, because I'm also a mentor here at Excersim, will review your solution and give you some feedback how to improve. Then you can also watch community solutions, and that is a big benefit because some people have very good solutions, like for example Sen Vital here, who is also doing just a one-liner with that. Interesting enough, he wrote the 10 million out, but the solution way is exactly the same, which is pretty good. The only thing that is a bit weird, and I should maybe write the maintainers of that project, is that the GigaSecond class is not really used. Because if we look here, that is interesting somehow. But yeah, fair enough. Okay, but that was a bit too short, I think. So I would suggest, do you have an idea what we should do? Or do we just take the next task? I think we just jump right into the Raindrops task if there comes nothing else. Cool. Okay, guys. So Raindrops. Your task is to convert a number into a string that contains raindrop sound corresponding to certain potential factors. A factor is a number that invariably divides into another number, leaving no remainder. The simplest factor of another is to use the modulo operator. Okay. The rules of Raindrops are that if a given number has 3 as a factor, has 5 as a factor, okay, so there are different things that we have to output. So, that means if we get a 28, has actually 7 factors, but not 3 and 5, so the result would be blanc. Okay. 30 has 3 and 5, and so we get another one. But they are combined. Ah, that is interesting. So if 3 and 5 is a factor, then we return pling plang. And if 34 is not a factor, we have 3, 5, or 7, we return just the number. Okay, so we start again, we download the exercise, going into our Visual Studio, call that thing, open up the workspace. In that case, we go 1 or 2 back, and we go here to the Raindrops folder. Okay, so the same thing again. We get our project, we get the packages. Should be fairly simple. And now we have again the option on the terminal to run pub run test. And if the packages are downloaded, I think that should run in a second. Ah, here we go. And now we get again some errors. The method convert isn't defined for the class Raindrops. Okay, that sounds exactly like the error before. So we have the Raindrops, which is a class instance of the class Raindrops. And this Raindrops is most likely inside of our lib folder. Okay, so this time we have to give this method convert inside. So we want to convert here. And what do we want to convert? 1 into a string. Okay, so we get a number and we want to return a string. So we return a string and we receive an integer number. And we want to do our code here. And for now, we just return null just to check if anything is working. Okay, so now we execute pub run test again. And null is not an instance of string. Well, that is absolutely correct, but to fix that, we can just make it like that. Instead of returning null, we return just an empty string. And this leads to following. Yep. So we get an error because it expected 1, but it received nothing, which makes sense. So to solve that issue again, we just write a 1, and now the test should be green. Perfect. But this, of course, is not a solution, but it's part of the test-driven development. That means I'm writing something that is as minimal as possible for that, and now I'm going back to the test and try to fix it. So in that case, we have the 1 here, and I want to fix now this convert solution for the next one. So I call that now skip false, because all these tests are skipped, and I have to unlock more or less with every test that I have fixed the next test. Okay, so I fixed the next test, and if I run, we should return pling, because the 3 is a factor of 3, right? So it is divisible by 3, and then we should return pling, but we don't do that yet. So let's go here. So the assumption is that if the number modulo 3, modulo 3, that means we divide the number by 3, and this number we divide the number by 3, and we get the rest of this number. So, and we want to check if it is 0. That means it is divisible by 3. And if this is the case, we return pling at the moment. Pling, what a word. So, and if I run the test again, we should be happy to see all the tests passing. Okay, now we are going back into our test. We unlock more or less for ourselves the next test. Call it false. Run the whole test. And we get the next error because we return 1, but we should return plang. And the assumption is that if we get a 5, we have a modulo and 5 because it's factor 5. And factor 5 should return plang. Okay, so I take this plang word with us, going back to that. And what I can do is just do it easy right now. So we just say 5, 0. And instead of that, we just return the string plang. And I think I can also remove that just to make it a one-liner for now. Okay, and if I run the test again, we will see all tests are passed. Beautiful. Next. I think that is 7, and we return plong. Well, I think you know what we will do now. We go here inside. We more or less, how was it? Yeah, this one. I just copied this one and say 7. And we return, what do we return actually? Plong, of course. Good. So this is the assumption that we have. We run, everything is green. So we have 4 tests that are green and 14 to go. So we go and make that false, run the test again, and we get this is also working fine because we return the, why is it working fine? Because it's a factor of 3, so pling is returned, which is fine. So we say false, and the next one. So we have 8, and 8 should be the number. So this time, the first time, we have the problem that we don't return this one. We have to return the number to string. Okay, so if I run that now, all tests have passed. Good, back to the test. We unlock the next one. And we try it again. And the next one, because everything is green. That looks pretty solid. I thought to get more problems in that either. Okay, 9. So now we have the first time that we have a factor that is in 2 numbers. So that means we have 15, which is 3 and 5. So let's see what happens. We get an error because we want to have now both combined. So pling and plang. Interesting enough, why is it first pling and plang? That is a good question, but I think we always have to consider 3 first and after that 5. So what we want to do now is we want to create a string out of these things that we have. The good thing is we have already that logic. Now I could write a lot of code or surrounding it, making maybe a loop or something, but actually what I want to do is I want to what can I do? I can write a method for all of them, but that is maybe too much. But the problem is I don't have to return actually anything. I can just make here that I can write a variable that we can call return string, which is an empty string. And this return string, or instead of a var, we can just say it is a string. this return string gets returned. So return string. And instead of return string, I think the better name would be something like, is there something like rename? Ah, yeah, F2, all right. So instead of return string, we are saying more something like result, because that's it, right? And this is not an empty string, it is more the number to string. So in the default mode, if everything works fine, we return the number to string. And now instead of returning returning immediately the words, we have to add that to our result string. So what we will do is result plus equal pling, plang, or plong. And because we made it already in an if statement, we say we add the result that string. And at the moment I just saw that we just add once the string. So I didn't see something like pling, pling, plang, or plang, plang, pling, or whatever. And with that, I think that test should be fine already. Let's see. No. Oh, no. So much bad stuff. No, of course not, because what I didn't check was that if we have, that's a good point. So the problem is that the number stays inside, and now the number of the result stays in front of the string. So what we have to do here is we have to add somehow, how can I do that? I could just add that, I could make that an empty string and make a check if we are running in one of them. But that would maybe mean that I have to create a Boolean or something. So as an easy solution for now, I just will keep track if we are jumping in one of the if statements. Hi guys, new viewer, you're amazing. So let me think about it. So we have a Boolean that checks if we are having a factor. So, and this having a factor is getting checked inside of all of them. So I will create that and we'll do this. So, and now we have to add, of course, the semicolon. That was a mistake. So, and semicolon. And if I save, we get that now. So, and whenever we jump inside of one of these, we have now having a factor to true, having a factor to true, or having a factor to true. So, and now we have to set this having a factor to false. And what I will do now is at the end, I just check if having a factor has been done. And if yes, no, that is not a good idea, right? Because now, yeah, I can do the opposite thing. So I just say this result is an empty string. I add pling, plang, or plong. And at the end, I check if having factor happened and if it not happened. And if it not happened, then result is just the number to string. Makes this sense? So we have our result, we add pling, plang, or plong. And at the end, if we check that we have jumped in one of them, and if we have, then we just add, return the result. And if we don't have jumped in one of them, then we just return the number itself as a string. Okay, so let's run the tests. Okay, that looks pretty good. And now let's unlock more of the tests for us and see if something has changed. No, all good. All good, perfect. Next. And another one. Well, that's pretty solid, I think. Should be fine. So let's see if we can make the full task here complete. Yeah, it looks good. So, and this one. And this one. So now let's run it again and let's see. Yeah, all tests have passed. So with that, our solution is done. But now I could just push it up and say, hey, I'm done, right? So nothing left to do. But you see, already this deleting of my comments is a very important step because it is refactoring, right? I'm looking at my code and thinking about how can I make that better. And for example, a to-do is never a good idea to leave in production code. So for that, I will remove it. And especially if we can remove a to-do, it's really important and very good feeling for yourself. And of course, also put your code here. It will not help someone in the future. Okay, so now we have to think about it. We have the method convert, which gives us a number. Is there any idea which number we get? No, right? It is just any number. So it could be anything. Okay, I don't make a passive active working here. So what we could do if I would work here in production code, I would make it passive. So for example, I'm not sure how it will behave with negative numbers and everything like that. So I would add here some more guards that my function will always work. But today that is fine. Okay, then we have our result string that we make empty in the first place. Then we add all that stuff and this looks so like everything is the same, right? So I'm pretty sure we can make that more easy, I think. But how? We want to set this to true. And if we're jumping in one of the functions, we want to do that. The question is, the good or easy way, instead of doing this, what I can do is I could say, that would be a good idea. So instead of just jumping into all these different ways and saying having a factor at the end, what I could do is I could just say, I try to parse the result. Try parse, I think that is possible. So I take this number here and I give it up here, whoops, number.toString. And now we know in this result could be a number. But whenever I add pling, plang or plong, it is not possible to parse that number anymore. So what I will do at the end is I say result, and now I can do something like, no, I have to take the number, of course. So num.tryParse. So I take a string and try to convert it into a number. And if I do that with the result in that case, it should throw me an error, it should be null at the end. So what I could do is I can say that the result equals try parse. And if this is not possible, wait, slowly, I make a mistake right now. We don't want to do that. We can try parse it. And if this is failing, what do we do? If it's failing, I just return the result, right? So if I try parse, I would return or get a return of null. But this is not actually what I want, right? What I could do is I just parse it, and with that I get an error now. So I could try. I don't know if it's getting easier with that. I'm not sure. I don't like that. It's maybe too much. But I really don't like that having a factor here. That's not very good. We have the factor 3, 5, and 7. And depending on that, we add a string. We could write a function for that. Then I can at least get rid of this having a factor. Maybe that could help. So instead of doing this, I can do something and write a function that returns void. Or better, yep, let's do that. I just take that for now and create out of it extract f method. Doesn't work, okay. So what I want to do is I want to factorize it. And if I do that, I want to return for now void. And what I want to do is I want to make exactly that call. And what I want to do is I want to have a factor that I want to check. So I will give it an int factor. And I want to give him a number that I want to double check. So int number. And having a factor is now pretty easy to understand because it is just the first thing that I do. I set that to true. And after that, I have to return, depending on the different numbers, different factors, the pling, plang, plong. Is that useful? I have to change that. No, it's not really useful. It's also not pretty good. Don't like the idea. Sorry, guys. So we have the solution, but somehow it's still ugly. Another thing that I could do, because we don't return in any case, I could use it and take these booleans up here. So I can say dividable by 3 and give it this part inside. Up. And say if divisible by 3, we have now this plane. And now if I say bool dividable by 5, we have this part. And last but not least, we have divisible by 7. Divisible by 7. Why can I do that? Well, because we don't, we have always to check all 3 of them. We can put them one level up because that will not interfere. We just make 3 times the check in any way, in any case, so we don't return somewhere. So it doesn't cost us anything. Okay, so we have 3, 5, and 7. This is working now, but now instead of doing this, this, and this, I just use once more. The challenge is to make it better viewable. So for that, I just make it like this. And the having a factor could be much easier by saying having a factor equals dividable by 7 and, sorry, it's or dividable by 5 or 3 or dividable by 5. Good. So this is having a factor. And now we are just doing this once and we get nice little one-liners for that. Having a line, I think that should be fine. We get this as a toString method. We get the number and this has to be, of course, an empty string. If I execute the test now, we get 18 successful tests, which is exactly what we want. It is readable for a developer, I think. We understand that it's divisible by 3. These are the checks that we want to do. We have the different if statements that actually do our work that we want to solve. And we have a factor that we also want to do. And then at the end, we return the result depending on what we need. Okay. Do you see anything that I maybe missed? Should I add something that I have missed right now? It's funky that you are 4 seconds behind or 10 seconds behind me, so I'm always speaking and Okay, so let's go further. I think I can push that also up to Excersim, and I submit that with Excersim now. Submit, and we add the file name lib and giving the Raindrops start. And with that, we have solved this next problem. And if we check now into our Excersim, we can actually see our solution here. And now I'm really curious what the community solved, or how the community solved that problem. So let's have a look into different ones. So this was exactly what we had before, right? Check if factorial. So this is looking pretty good and should be exactly what we had before. What is else? Yep, that is also very fine. But how did they do it? They checked if the final value is empty. Oh, I think that would be a nice solution. That is a very good one. Yeah, sure. So we have here a ternary operator, and the ternary operator says if the final value, or result in our case, is empty, then the value .string is right, or we have the final value. And I think we should actually optimize ours with that idea, because all of that things here is pretty fine, but I think this is way easier. So we remove the having a factor, we remove that having a factor to string, and instead we are just doing if the result is empty, with a ternary operator, we say return the result to string, right? And else, is that right? No, the number to string, or else we have to execute that, I think, or else we have to return the result. Because is it empty, then it is this. Then we want to return the number as a string, and else we return the result. Then we don't need these dividables anymore because it makes it just hard to read. So I have to inline them by going inside, taking these things again, because it's just overhead if I'm doing that. Voila. And voila. So. And as I said, it is a training session, so that's why I'm optimizing my own code, because I want to learn from others. Exactly. So this is, of course, a way better solution than I had before. Way less code, much better to read. Everyone understands what's happening. So, of course, I will optimize my one to that. Very good. So this is our solution. We can complete this solution, and I think we can be happy with that. Okay, next. So what do we have else? We have the RNN transcription. Yeah, so RNA is pretty easy to understand, right? Or DNA. So what we want to do is we have different patterns of letters, and we want to find the different part of it. So G has C, C has G, T has H, and so on and so forth. This is a string understanding. I think it will be working with lists if I'm right here. So let's go into it, I think, right? We download again the Excersim one. Oh, good point. I can of course run the pub run test again if the solution is working still. But yeah, it is still working. Thanks for reminding me. Completely forgot. Okay, but still, we can go to the next. Okay, guys. So we can go back to the next task, and that would be the RNA transcription. Taking a good sip of my water. Now we download again the task. And if we have to download the task, we just jump into it. And we are going to the Dart track. We have here the RNA transcription, and have a look. Get the packages in the meantime. And what are you doing at the moment? Pre-compiling executables. Okay, so now we have again the same problem. We have a lot of tests that are failing. Well, very good. And the good thing is, as far as I can see, we want to return just a letter, and later we want to return a lot of letters. So how can we do that? Okay. First of all, I would say we make this one runnable. So toRNA is a solution, or is a function that we have to add to our RNA transcription. And we return void, of course, add this toRNA and take a look how it feels, or what the test actually do. And the test is still red, because of course we get an, sorry, not really used to the Visual Studio Code, so sorry if there is something wacky sometimes. So we get a string, and we want to return a string. Okay, so we go here, we return a string, yep, and we get a string inside, which is the DNA, I assume. Whoops, that is not the parameter, that is something else. Okay, so now we have toRNA, and the tests are green, and with that we can run the tests. Run test. And it's failing. Well done. Very good. So what do we get? We return nothing, and it expects an empty string. So what we will do, as easy as possible to fix the tests, we just return an empty string. And this should pass already the test, which is very good. And we go further to the next and say to that false and try this one out. Okay, so the actual is empty string, but we want to have a G. And where it comes from is that the C is a string, is something, and empty string is not good for us. So what we want to do is we only want to return empty string if DNA is empty. So DNA is empty, then we want to return empty string, else we want to return DNA. Oops, so. Or better, we learned we want to return G. Sounds like a very silly behavior because we just return the string itself, but this is exactly what test-driven development usually do. So we try to keep the effort as minimized and then bringing the biggest changes first. Okay, so what I can see is, because I saw already the last test, is that there has to be a differentiation between one and multiple letters. But this comes later. Let's start with the C now. If we get a C, we want to return G. So what we want to do is we want to make the test a bit more better. So let's have a look what we can do. Else we want to return result. And the result is a string. That is an empty string for now. And now we can say if DNA equals to, or is there something that maybe a bit better, like check or something, split to map, trim, all matches. We can make a regex, of course, but I don't know if I like that. We can replace it. Oh yeah, I think replace is a good idea. So we replace all, and we replace, oh, I think that is a good one. Then we can replace all of them in the future directly. I think that is pretty good. So what we can do is making DNA replace all from something with something that we want to replace it. So what we want to replace a C, for example, with a G, right? And with that, we want to return the DNA at the end. The only thing is that I have to check if it is a mutable function that replace all or an immutable one. So do we return with replace all something? No, we get back a string, so it is immutable. So we need to have here a result. And this result is now our G, hopefully. So let's try that again. And yes, the test has passed. So all the C's inside of our DNA string is now gotten to a G. Very good. So the next one, what we can do is we can have a G, and if we have a G, we want to have a C. So what do? Yeah, we get an error. So because we want to more or less do the same thing again, and instead of using the DNA, we want to use now the result. And we want to say the result equals the new replaced string. And now we have G, and it should be C. Is that a good idea? Because now if I'm coming over and I change it first to one thing and then I change it to another thing, I think that leads to a problem sooner or later. I think that will work with one string letter, but it will have a problem if we have multiple ones. Okay, so how can we solve that? But keep it for now. Let's see, we fix our test first like we have to. And expected G, but it returned C. That is weird. Result, replace all G's to C. And because of course the second test is already failing. Yeah, that is very good. Okay, so that is solved that issue already. So what we can do instead of doing this, because of replacing, we more or less change the behavior again. So if I do this, we just change back the C to G. So this is not a good solution, I think. What I will do now is, because I think that is a bit better, we can use the DNA and split the whole thing. and I split it just with every letter. So every letter is a split. So what does it give us? It is a list of strings that we get back, and I call it for now DNA list. So, and this should give us a list now. So why I'm doing this? The benefit of a DNA list here in that case is I can, for example, map over it, I can iterate over it, and then I can work with every element inside of it. So DNA list, I can map it. So every element that I get, so every string, how do you call one DNA part? Is that has that a name? DNA returns its RNA. Okay, the RNA is the opposite part, but we want from the DNA every one. I think it is the name nucleotide. All right, nucleotide. Let's take the nucleoids, and we want to return. Depending on what we get, we want to return something else, right? So, for example, I think we can even write a switch statement here. So nucleotide. All right, learned something today again. So if it is a C, we want to return G. Turn G. If it is a G, we want to return C. Voila. And I think if I'm right, this map can now be collected to a list again. And this can be... okay. So, and this can be joined together again, and now we have our string. So that could be a result. Var result. But this looks ugly, and we have to join again and doing all that. What we also could do is we could use the fold method. And what does fold do? Fold is usually for things that we want to add up to something. So if I give you an example, if we take the DNA list and we say fold, we have now an initial value, which is for me an empty string, because we get every single one of them. And now we want to add that to that string that we want to return. And this empty string gets now a combine method. So, and this combine method has a previous, which is nothing else than this empty string at the beginning. And we add this previous now something to it. And in that case, it's the element itself, or the nucleotides. So, and we return something. We return pref plus. Now we need a method, I think. So change to RNA. And now we give inside the nucleotide. Yep. And the good thing is we add this pref. This is missing parameter type for pref. Okay, so you need some that is string in that case. You know what you are. And this is change to RNA. This is a method that we will create in a second. And this is our result string. Voila. So, and now we have to add or create this method here. And what I want to do in this method, we want to return a string, or even better, a jar actually. And what we want to do is, depending on the nucleotide, I want to return something else. So if we get nucleotide equals to G, we return if nucleoids is, so I have to if statement here. And if it is that, we return C. Voila. And we make 3 of them. So we have G, C, and return G, or whatever. And this here is a string again, and this change to RNA is getting used here. So why is it red? Because it could be that it returns nothing. Return nothing, which is also pretty fine. Good. So now that means we have this method change to RNA. We get the nucleotide, we push that up here, we add that to our previous one, and now we get a string concatenation with all the different nucleotides, or better, the RNA nucleotides. Okay, So if DNA is empty, we return empty string, or we return the result. And I think we don't even need that, because if we don't get anything down here and we don't return C or G, we return nothing. And if we return nothing, we don't need all of that. We can just return the result. And yeah, let's see if that works. Do you have any questions regarding to the fold function? Because it is really handy. You really should use that more often. I always see that and somehow I never use it, which is sad. So let's add some more tests and see what we get. 2 more failing, very good. Because A is empty, if we get a T, we should retain A. So go down here. Now we have this nice little method and we can just add this part. So T, we return A. And I think the other one was we get an A and we want to return a C, if I saw that right. Oh no, a U, of course. Obviously. So a U. And now test it again. Cool. And the RNA complement. So this is the final goal that we actually wanted. So we get a string with different words inside, and we want to check if the outcome of our function is actually the real RNA. And all tests has passed. Well done. So hey, bit happy that it works out that well. Hey, with that speed I can really finish that exercise and I didn't thought that. Okay, but now let's have another look. How can we maybe improve all that stuff? So for example, that list up here with the DNA split could be separated, and I think it will be separated for me. I like it more. But this result here down here can be actually taken up here, I think. We could just return this one because it's already the solution, right? And now, if I see this, somehow I get the feeling I could also take this split command here, put it here, remove that, and now it looks like a one-liner, and I'm pretty happy about one-liners. So if I just make it a fat arrow, we have the DNA split, we fold it, as I said. We add it always to the string, we put everything together. We have that nice little function that does it what we want to do. And I think that's pretty neat for now. Do you see any optimization that we need to do? Run the tests once more. Cool. So the tests are running fine. And with that, I think we can submit our solution, right? Lib MA. What? RNA transcript. Ah, this is RNA. Right. Oh. What? Command. Ah, this Excersim. Okay, let's try it with the right wording, then everything is fine. Good. So with that, we got the next solution here. And if we take a look here, we find our solution. I'm still pretty happy with that. I think it's very easy to read. I don't understand why we have here 2 lines. That is a mistake, I think. I can remove one of them. I don't actually see the benefit. Yep, way better. I didn't know that it works like that. Interesting. So let's run the tests once more. Yeah, but everything is the same. Good. Cool. So if we go here, we reload. Looks much better, I think. Good. Could we take that together somehow? I don't think so. We could maybe make a switch statement or something, but it just would be longer. So I assume that it's pretty good. So let's complete this solution. Oh, I saw another thing that we could maybe add. The comment was still in, and as I said in the production, I would never do that. I hope I can still comment it. Yeah, cool. Okay, so let's take a look at the community solutions. What do we have here? For example, Kenny Avelono. Oh wow. Substring GTA. Wow. Okay, it's a possibility, of course. He's also one of the maintainers of the exercise and Dart track. So if you have any questions, you can ask him. Okay, so we have the nucleotide. We get the GZ, yeah. So he solved it with a switch statement. Oh, and that one is very good. He made also a default which throws an argument error. So if you add a nucleotide, which is not able to be converted, it throws an error. And this is passive programming, which is pretty good. And I think the fold method is a bit better than this mapping and so on. But yeah, it looks pretty much the same like we did. Maybe one thing as an addition, the class RNA transcription should have contain, of course, this change to RNA. It should be part of it. So submit that one too. Cool. So I really like Excersim solutions because you get more of your brain into the usual programming and you can see other people's solutions. So that is a very good one. And I will also try to make once or twice another stream. But let's fix also the anagram problem, right, friends? So the anagram is something like given n lists, okay? The program should return a list containing inlets. An anagram is a rearrangement of letters to form a new word. Given a word and a list of candidates, select the sub-list of anagrams of the given word. That means this word comes in and we get a list of words and we have somehow to check if one of the letters inside of this or all of the letters of this return is inside of these parts. So nlist is too long, Google is completely wrong, inlets is exactly the right one, and banana is wrong. Okay, so we download the problem, yep, and bring it up here. Going again into the RNA transcription, Dart, here we go, and anagram. So open that one up, getting the packages. Another nice sip of my water. It's not too bad for my first stream, I think. So some of the exercises directly solved. Pretty good, pretty happy with it. So let's see what we can do here. Dart run test. Let's see if we can run already. Nope. So what is the problem? Lib and test. Okay. So test no matches, anagram find anagrams, and then we have a string list that we get and a string, of course. So exactly what we said. So we will take find anagrams, put that here inside of our code. And what we learned already, there comes a string, which is the anagram, and the list of strings that, what is that? That is the comparison list, maybe, yep. If you have better names, please let me know, because, yeah, it's always. And find anagrams, now the question is, what do we return? We return the string, and actually we return a list of strings. So that means it could be that one anagram is twice inside of our list of anagrams. Okay, so we return a list of strings and that's it. Okay, so before we start, we return, of course, null, just to see what happens if we make pub run test. Yep, we get an error, which is good, because we want to return an empty array, which I can do easy enough. And let's see what we get. All tests have passed. So what is the condition actually? So diaper looks into all of these and doesn't find a word that contains all of the words. But yep, let's see what the next test brings us, because it works, right? Why should I work on that? Okay, and now we get the expected one is stream and mate mates, and both of them has to be part of this list that we return. So back to the drawing board. It seems now we have to work actually. So the problem is that we have a word with a lot of different letters, right? And what we have to do is now we have to compare one word with another one and have to check if all the letters of the one word is inside of the other word. So I think what we have to do is we have to iterate over the words or over one word. And I think we should, how can we do that without getting too crazy? The problem here is it could be that this is a very expensive operation, because if I use one word and I have a list with words and I would now do, I take the first letter and check it against these all letters. Then I go to the next word and check it against all these letters and so on and so forth. If the list of comparisons is very, very big, we have very quickly a performance issue here. And if I take just the word of anagram, I will not get the solution, right? So that is getting a bit trickier, I think. But what we can do. First, we have to check the words of the comparison list, right? So for every comparison list, for each, I just do it like that for now. We get a word and every word we want to check. So what can we do to check every word? We have to check the anagram and the word. So I would do maybe, what can we do? We have to split the word, and after that we have to iterate over the splitted anagram. So most likely we will have to do something like that. We have to have a list of string, what we call the anagram reference, which is anagram.split, and we split it just with every single letter. And now we have the word, and we have also to make the word, we have also a list of string that is the word reference, which is then the word dot split on every letter. So, and if, now I have to compare them. And the best thing would be if whenever I find that a letter is not inside of the anagram, or better, a word of the, a letter of, whenever we have a letter that is not part of the anagram, we directly finish that, that word. We just jump to the next one. So, and this is what we have to do here. So for each is maybe not the best one. I'm not sure yet, but let's see. So what we want to do is we want to go through the word reference and say for each again, which is the bad thing. So this is the letter. And what we want to do is we want to check the anagram reference. Wow, that is so bad. We have to iterate over both of them. So what I would do is maybe make a word is like varchar in word. Is that possible? Word reference. And now we get every char of this reference. And now I have also to make a for loop over the anagram. So char ana equals in anagram reference. And now I have both of them, right? We go first over every letter inside of the word reference and check it against every letter inside of the anagram reference. And now we have, so what I can do now, I can check now every char inside of the word reference against the char in the ana reference. So what I can do is I can say char equals char ana. Oh, that is not good. Wait, slowly. First, I can directly skip the word and go further if the word is longer or shorter than the anagram, right? So if word.length equals the anagram.length, then we can do all that stuff here inside. So else it makes no sense, because if the length is differently, then the thing is already wrong. So next part. Now we have these two, and what happens is we get one word of the word reference, and now we go through all the words of the anagram and check if it is part of it. So how can we do that? We take the char of anagram and check it against the char. And whenever it is, but what happens if it's twice inside? Ooh, that is not an easy solution. That is not an easy problem. Let me think about it. We have a word reference where I go through all the different and now I get here a true or false. And what I have is, I get here, for every char in word reference, we get the word, we get the char, and for every character I want to know if it is inside of the anagram. And what then? Now I make the check over every word, but what next? If the word is an anagram, what happens? If the word is word anagram would be something that I have to say. So, and if this word is an anagram, then we have to add it to a successful list. So this list has to be the result list up here. So we have a list of strings. That is the result list. And what we have to do is, when the word is an anagram after that for loop, is it after the for loop? Yep. Inside of the for each, we have to say, okay, if the word is an anagram, we have to add it to this list. So in that case, the word. Okay, and now we have to identify in that part, is it an anagram or not? So, and I say we check every letter of the word with the letter of the anagram. And if, so what do we check here? We check the first letter with all the letters of the anagram. So it is part of it. We get a true back, right? Okay, that happens once. Why should I save that? What is important about it? So the char is in word reference. So we can actually say it is an anagram and be sad if it is not. I think that would be better. If is word anagram, then we add it. And now we say if, yeah, perfect. Is word anagram equals char ana equals char. That means we check now every single letter, but this is maybe not a good idea. Interesting fact. Let's take a look and let's see what happens. And this returns the result list, of course. Whew. But now let's check if the test is failing, most likely, I think. Yeah, so it is still empty. So we never add something to this is word anagram is always false. So, but if I'm right, this word list is already correct. So we print here the word. And that should be fine. What do we get? Yeah, stream, pigeon, and mates. And what is our anagram that we get? Master is our anagram that we get. Master, master, master. Okay. That means the stream and master, yeah, that should be an anagram because the char s is here inside, which is true. So then we go to the next one. And so further and so on. So what we can say here is something like if, no, somehow it's getting false. Yeah, of course, because we do it for all the anagrams ones. But of course we want to, yeah, okay, I see. We don't want to do it here, because as soon as we come to the next letter, we override, of course, again, the is word anagram. Is char part of anagram is the important one. And this is the test that happens here. We make the is char part of anagram equals char ana equals char. And this is char part of anagram is true for every char. And if this is true and we're coming through all of them, then we know that this char is part of it. And what can we say about the word? Can we say the word is now an anagram? Okay, we have to identify if this word is an anagram. And we get the chars. So now we want to return something. Is word anagram equals, no. Why would I override it? We go the first time here inside, we identify, okay, this char is part of the anagram, which is perfect. And then we search in the anagram if it stays there. And if it stays there, we add this char. But that doesn't say that the whole word is already inside. It's just saying that this char is inside. So, but what we can do is we can is char part of anagram, because all of them has to be part of anagram, or else we make a mistake, right? Is char part of anagram, then we can say continue. Else we break. Let's see if that works like I expect to. Must have static type of Boolean. I thought that is the case. Yep, okay. Let's try it. No, still not. We get now all three inside. Stream, pigeon, maters. I'm thinking too complicated, I think. Something is wrong with me at the moment. I didn't do it for a long time, this stuff, so let's see where we have the problem here. If you have an idea, please let me know. Okay, we have this list. We go over every word in the list, which is absolutely fine. Fantastic. So now we know that this word is an anagram. We just assume that in the beginning. And now we print the words, which is not necessary, we know that. Now we get the chars from the word reference, and now we know that char is part of the anagram, which is, in the normal case, true. And inside of that char ana, we just set this value. So if this is Boolean, we can just say is part of anagram equals to the char ana equals char. So, and I would say this is part of anagram. We can filter and let's see what's happening after, what happens after that for loop. If it's still part of it. And char ana, yeah, sure, we have to compare it. Okay, so let's run that and let's see what happens. Ooh, a lot of falses. So we get it true sometimes, but it seems not to be often the case. Why? It should be a whole word for it, right? So every letter of the anagram is over that. Where is that? We have that anagram reference, and we should go for every char in that, and we print for every char of that. But we get 2 times true. That makes no sense. What is wrong with my brain at the moment? Okay, let's think about it. We have the part of the anagram which is true. We for loop and we set this part to whatever this returns us. So if they are two together, the letter is part of the anagram. But how can it be that only two letters of that are exactly the same? I thought that there needs to be more. That is weird. So let's see what we get. Print char ana and print char. And if I let that run, let's see what we get. A lot of text most likely. So yes, but as you can see, RM, it's a good point. I don't know. Okay, that is maybe a very bad idea to print it like that. But what we can do is we just give it a string and add this and also the char here. And now let's see how the result looks. And run. Let's see what we get. Okay. MS. So master is the anagram, right? So we get a lot of S in that case. That looks weird. Oh no, that's correct, because char is not changing, right? And char ana is changing. So we always go over master, 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 and so on. And now we check is master, and the S should be inside. So we have it once true, which is absolutely fine. So that means we have for that word one letter correct. Wow, that is so sad. Is word an anagram? So if the char is part of it, we go, of course, a lot of times inside. I don't need, if I know that this char is already an anagram, I can go to the next char. I don't have to wait till something happens, right? So if this is anagram, part of anagram, we set it to false in the meantime. And if it is part of an anagram, I can just say is part of anagram, if is part of anagram, and I think I can just say continue, so it jumps to the next char in that case. Let's see what it happens with my test, with my prints. It should be way lesser, but let's see. So I thought here it would be finished, but maybe the continue is not doing what I expected. So let's see, Dart continue for each. How to stop darts for each. I think that is not what I want. That is a break. A break would finish the whole for each for that. I can, because what I think if I do break, it will stop completely. So this is true. And now well, we can try with a break. Let's see what happens now. So what I want to see is that the S is just checked till to that point where S and S are equal. So I think that is true. I can take this value here and add that to the outcome. And let's run it again. Yeah, so that is actually working. Okay, but now we have the is part of anagram and it doesn't do anything. So, but what I want is in this for loop, I would now to see that it stops. Does this work with a for each method? So if I say word reference, no, I can't imagine that this is working fine. So what I want to do is I want to for loop that, and if, then I want to break it or continue it. Am I here in the wrong position? Let's try it. So I take now this and say word reference for each and say word. Yep, word, and want to execute that. So voila. And I add all of that. Let's see what happens now. If I enter here, instead of continue, I say break. What is wrong? A break statement can't be used outside of a loop or switch statement. Interesting. Okay, now he don't even understands anymore, so it can't be for each in that case. Cool. But he understands this break, but he just don't do it, even though this is true. Ah, but maybe I don't want to do it here inside. No, but if I break it for char Anna, that would be maybe a solution. But no, I want to break it. I'm already inside here, so that is the problem. So as soon as this gets true, I want to break this char Anna completely, because I don't have to do it anymore. I know already that it is part of it. So what I can do is I can check that, I break it, and let's see what happens now. If I get removed all that stuff. I forgot to print it anymore. Leave my print, cool, and try again. So SSL, perfect. So now we actually manage it, that we just search as far as we need. And as soon as we get one true, we jump out of that. Okay, so we jump out of this, and we have now the option that we can also jump out of this. So we also break that letter here. I don't know if this is true. Yeah, it should be true. Let's see what happens. Yep, it should return even faster. Okay, so we have these three, and we jump to the next letter, and we have MAS, SP, I, G, E. No, I think that last one is wrong, because we don't want to jump out if the letter, if the wording is wrong. Okay, what a day. So what do we get out of this information? Now we know this is part of an anagram. And we should save that in a list of booleans maybe. Or does it make sense? Okay guys, I'm not coming on it. I have to go shortly to the bathroom, so I will make a short break. Sorry guys, and we'll see us in a second. All right, till later. I think this way. Okay, cool. All right, so I'm back, I think. Cool. Okay, so back to our anagram. Let's Google, or don't. Wow, 1 hour already. Jeez, didn't expect it. So, okay, the anagram. What we want to do, we check a word, every single letter of this word against another word with every single letter. And if all of the letters of the anagram are part of the letters of the word reference, then we want to have it as an anagram, this specific word. So we want to add that, okay. But now at the moment, the is word anagram should be is always everything, is always true, because it's never set as true or false. What is the actually solution for that? We get the char and the char in the anagram. And if we know that the char is part of the anagram, then the is word of anagram is true. Is word anagram equals is part of anagram. Yes, that should be fine, I think, right? So if the char is part of it, then the word is part of the anagram. So let's see what happens. Really? Okay. I didn't expect that, but it was way easier than I thought. Why was I... Okay. So the only thing that I missed actually was that I didn't change the behavior of that is word of anagram. I'm not absolutely sure that this works correctly, but let's see what the different tests telling us. So let's go to the next test and set it to false, unlock it for us, and let's see what happens. Okay, all tests are fine, so it works well here. So next one. Aha, okay. So here's the problem that the expected one is just 1, but we get 2. Why? Which was Google instead of inlets at location 0. That is interesting. What is happening? It is here. So we have 4 and inlets. We come with in listen and n lists. So we have here the first time that we have 2 letters, and I think that will break our code at the moment. So let me think about, we have now 2 S parts, but Google is part of it. Why? At Google and inlets, I would expect that this one is inside, but why is Google inside? That's funky. Do we have any words? Inlets? No, we don't. Why is Google part of the anagram? How did we manage that? So if we look for the print statement, which word is coming? No, not that. It would be part of this is anagram because we want to know if it's part of it. But how did Google manage it to be a part of the anagram? So, okay, let's run that. And we get stream matus. Okay, that is fine. Then we have down here the Google inlets. But somehow Google is part of the anagram. That is funky. Okay. So where does it happen? We said if is part of anagram, we break already. So, we don't set it back. That is the problem. If we know that the word is an anagram, we have to set it back to false. But still, why is Google part of the anagram then? Is part of anagram is getting set back to false after every char. We break whenever we know that the anagram is part of it. The char ana is part of char. So when does it happen that this is true? So is word anagram is part of anagram. So this needs to be printed for me. So, and let's see what we get. A lot of truths actually. It would be good to get char, of course, too. So what I will do is say char and is part of anagram. Yep. So Google, there is LE is part of it. So, because the last 2 are true, and with that we set this to true because is part of anagram. So we go through the anagram, but the char is actually wrong. Whew. Interesting. How do we solve that now? So Google, we have the last 2 letters that are part of our anagram, and now we are failing, of course, of that. So how can we solve that? Don't print too much, but let's think about it. we get here a char that would be L, for example. Now we go through the anagram, we get now L somewhere. So this is part of the anagram. Why should the whole word be part of the anagram? That is not true. What we can check, if we solved once this and it is coming completely through, damn, that is also not good. No, what we have to do is we have to check the char against it. That is the problem. That's why we get here twice the thing. But the interesting part is that we don't come, because the first letter is, the first word gets already kicked out by the length of the word and the anagram. So because we split these two already and have the idea, we don't come into that listen problem. Now we have to understand this char is not part of this anagram. So what we have to do is we need to set something that gets only changed if the char is part of the anagram. So what happens if we run through that one and nothing changes? Or only the last two changes? I mean, if I check that and I'm going inside of here and I make my print statement with the char Anna. Wow, hey guys, a lot of viewers at the moment, not too bad. I hope you enjoy your day. So I hope I can show you something here with that Excersim lesson, but at the moment I'm just struggling. So if you have some ideas I'm happy to. Give me some ideas. Okay, so now we print that char Anna. So let's see what we do here. Okay, we get all of that stuff. So, but out of some I is part of Anna. I think I make it too complicated, but at the moment there is nothing that I can do against it. So that is that one. Yep. So out of some reasons we go through Google and we come false, false, false. We go twice through it. So that means that at least two letters are completely not inside of the anagram. The problem is I don't save the idea that if we go here once through a char and the char is absolutely not part of the anagram, the problem is this is the anagram that is part of it. But if we have one char that is not part of it, we should fail already. So actually, instead of giving the word immediately inside, we should say something like, we have to understand that up here already. So if that char is absolutely not part of the anagram, we should fail already. We come inside, we make this break, but and if this is the case, if the is part of anagram is here still false, right? So we never change that, then in that case we break here too. We break the char and even the word, I think, because the word is not possible to be an anagram anymore. So this is not true. And here we can now say is part of anagram false. But why just break? I think I have to do more. If this word anagram should be false then, right? And is word, why is it red? That code of course behind the break, that was not so smart. But now if the part is not anagram, we should break the whole thing. And let's see what happened. God. All right, so that was the mistake. So what I would, for all the newcomers, if you want to get a recap, so we're doing Excersim lessons and this one is the anagram part. So if you take a look here, inside of the .Excersim, we have the anagram practice and I just try to solve that. So yeah. So what I do already is we get an anagram that could be any word, and inside we have, and additionally we get a comparison list. So like a lot of words, and we have to find if the one word of this list is part of that anagram. And so what we get, for example, I can show you the tests for it, is like we get the word listen, and we have to find inside of this list an anagram. An anagram is where all the letters of one word exists in the word somewhere else. So for example, here it would be listen and inlets, but not nlists because it is longer, or Google because none of these are letters of listen are inside of Google, and the same for banana. So the solution would be a list with inlets inside. So what I will do till then is I create a reference where I have the anagram split. So we have every letter of this anagram, and we have a result list. And now we are going through each word of the comparison list. And what I'm doing at the moment, very messy, I know, but well, I hope we can clean that up later. I go for every word and loop for the anagram and loop for the word, every single letter. And then we check some stuff. So for example, here we check, is it part of an anagram? If yes, then we don't have to check anymore the other single chars of that anagram. Why do we do that? Well, if we would keep rotating and we have start with one single letter of the word and all the different letters of the anagram, it could be that the anagram is very long and we would run into performance problems. Or on the other hand, we have a lot of words and now we have to check and check and check. It would take ages to run performant. So I think, yeah, we have to optimize that even further. I think that is not the best solution yet. But if you have any ideas, please let me know. And right now, I managed it finally after, I don't know how long, maybe 20 minutes or something. I managed it to bring the tests again to Parse. And now we are going to the next one. We say false. And now we have 3 anagrams. Inside of LLG, we have gallery, regularly, and largely. Let's see how it turns out. Yay, that works fine. Okay. Now to the next. What happens if we have different anagrams with different cases? Oh, big letters and low letters. I didn't check that, to be honest. So I think, yep, will fail. Because I didn't check against small and big letters. So let's see what happens here. Actually, it could be pretty easy because what I could do, I don't save the letters itself. I just check against the reference. So what I can do is I can say char to uppercase wherever I use it. So the only case where I use it is here. So I can just say to uppercase, and the same thing for here, so that we can compare these two strings. And I don't know if the string has not, it has a compare to, compares the string to other, but it returns an integer. Why is it returning an integer? Compares the string to other, returns a negative value. Ah, okay. So it is sort then at the end? Is ordered before? Interesting. Ah, no, compare to is for sort operations, not to compare string by string. Sorry. So, okay. We have now the 2 uppercases, and I think that should already solve the issue. Yep, fine. Cool. Next, we go here. False, run the tests. I always have an eye on the comments, so... Have you ever heard of the Excersim part? Or is it the first time that you work with or see the Excersims? Good. I got here an OBS problem, so hopefully everything still works. Good. Tests are still running fine. Oh, go, go, go. What is here wrong? No, still the same. That is fine. Oh, hey. Count different the letters of the reference word, e.g. into a map char int, and then loop the map. Yeah, that is much better. Sure. Yeah, sure. Why I don't use a map? That is so much smarter. Ah. Okay. I will just finish up the test right now, but then, yeah, let's do that. Let's see if we get the test running green. But then we have, nope, we don't. So back to the true. And fix the tests one by one. and we go so. Okay, with that idea, we can think about it, and that makes so much sense. So what we want is we want to check the letters in a map, and then we want to count how many of the words are actually inside of that. And then we have that. I think that could solve the issue here quite easily. Why is that? Okay. Clean up everything a little bit and let's see what happens. Okay, count different letters of the reference word into a map. Then loop the map keys and then find there is the same amount in the lists entry. Okay, let's start with the map, I think. That is what we need. So char to int, I think char is not a case in... Is char a case? I don't think so in a Dart, but I would check. So we have a map with different chars, and let's call that reference map for now. So will be a string, I assume. So, and this reference map has to map into a map. So count different letters of the reference word. Okay, that would be not the anagram, that would be this one. Into a map and then loop the map keys and find if there is the same amount in the list entries. So we don't do all that loop stuff. I can nearly rip off all of it. Wow. Okay, let's see how we start here. Let's get the reference map. Now we get rid of nearly everything. We want to count here inside instead of doing that stuff. So let's see. Let's make here clean, just to keep the old stuff, but don't do too much. So we want to have a string map where we keep all the letters of the anagram, and then we want to count that if I understood that right. So we have the anagram reference where we have currently just a split map. But what I also could do is to map or set, not good, the word split. So you mean down here? And you want that I make that into a map. But still, I think I have to call it, right? Where do I... Let me think about it. Hey, what happens here? I have a list of string word reference, so now I get the word. So you would count the word with the But why would we count the word instead of the anagram? Because if we don't use the anagram as a reference, we have a word and we want to count different words that we have in the anagram. Okay, so let me think about it. We want to have a map of string to int here, and instead of just splitting it, we have to make a map out of it, because that split would give us just the keys, right? So that is what I understood. Wait, I don't know how to... If I can make the word reference to list, to set, to string, creates a set, creates... Nope. Do I not get out of this? I need to count the characters in the word. But do I don't know the count already? I mean, I have the word length here, right? Difficult with chat. I'm sorry. Let me think. We want to get a count where we have every letter of the word. So for example, we get Google, right? So we have Google, for example. And if we make now a map and I get the G, how would I count now against the anagram? Okay, I have to think first. I don't get it right now. Maybe I'm standing on the pain point. You need to count the characters in word. G2, exactly. Ah, right. And then I have to double check the amounts. Okay. So what I will do is I can iterate over the word reference. And because I need, of course, yep. So what I need to do is then I have to iterate over the word reference once more. So I just do it for now in this char in word reference. And for all these iterations, I need that map that I get. So I need a word map, which is a map of string to integer. And this is a new map. So, and inside of here, I want to count now the different chars. So what I will do is I add to that map, add entries. Wait, is that right? Yeah, I think so. Dot add entry or update. Can I? Update will be string key and then the integer. So I don't know if this has worked the way, but and in the other word you search for G's, and if there are two G's, continue, else skip to the next word. That is a good idea, yeah. So we have here char actually, and we update. That is function, or is it just the value that we give? Can't be assigned to the type int, function int. Okay, so this needs to be the update of that char, so it would be word map dot I need to get this entry after that and needs to have the information put if absent. Yeah, that is the first thing that I need to do. So put if absent, so we get the key, that is char, and if absent we add the 1. Don't know if this is, why is it complaining? Can't be assigned to type int function. Ah, okay, that returns in, that is value. Where? I'm working way too less with maps, I see. Map dart API. Let's see what we get. Okay, so that is clear. We get an hash map k and v. So that is our first string. This is the integer. All right, so what we want to do is we want to add an thing while an operation is being performed on the map, for example, in functions called during for each and put if absent call. Okay, what happens in the put if absent? We get a score of Bob. Here I think we also get the solution that I need. So we have a list of different chars, which is the key, and we want to add the key length. No, that is not correct, I think. Key.length, put if absent, key.length. No, because then we just get, what do we get here? The number here, okay. Okay, let me struggle a bit. So we get the char. Now we have the word map, and we put the keys inside. We don't have a value yet. We can add an entry actually, but only if we have not a new one. the new entry would be char to 1, I think, for the beginning, but still this is wrong. It is an iterable with new entries. Okay, yeah, that's multiple. All right. Map string into, okay. Oh boy, what is wrong with me? Word map dot add entries map, that is just that, remove that, update all. Put if absent, so we get the char, and if absent, is that a method? Calling if absent, and that is must not add or remove keys from the map. Okay, so if absent is just a function that returns the key value, so that is running like that, and we return something, most likely an integer. What is this if absent? Take a look. Okay, so it just returns the value. So in our case, if it is absent, we return, and I can do it like that, 1. So put if absent, and else we don't add it, so most likely I have to update, right? Can I do update? It gets me a string key with a function that returns an integer with the int, and then we have the if absent behind there. Okay, so we can use that maybe. So we get here an integer number. What we can do is just number plus 1, or even better, plus plus. So now we count the different chars. Let's actually see if that works, because at the moment I'm not 100% sure here. But let's see, print the word map with the, for example, G. Let's see what happens. Or can I just print it to string? Yeah, I think that should be fine. Let's see what happens. Key not in map s. So that is fine, because what I have to do is, of course, add the is absent function. So what is if it's absent? We have just to say the number is 1. And this is a named parameter, so we have to say if absent. Voila. Okay, so try it again. Way better. Okay, so we managed it. Do we manage it with the Google thing? So we get all tests passed. Okay. Because the last one I made that back. So let's see. So now we should get our Google one. Where is it? The test, and then... Okay, it's getting for everyone empty. The patter. We get tapper and we need patter, but we expected an empty. Okay, do we get anything double? No, we don't. So that is exactly what the solution would be, right? So finally, some progress. Sorry that I took that long, but slowly I'm getting it. So now we have that map, and that has the benefit that we can now use it to identify how many of which letter we have from the anagram or not. Will it be not useful to have that too? And then just identify if all the letters are inside of the different maps. I think so. If we could do the same for the anagram, it would be helpful. Or what do we read here? You have already the word split. Yes. So you need to count the characters in the word. I did. Would be the contents of your map. True. And in the word, you search for G's. If there are 2 G's, continue, else skip to the next word. Makes sense. Yeah, sure. Then I don't need to have that whole thing. So I can just iterate over the word map now. So what I can do is there a for each inside? Perfect. So now I have the word, and every key that I have here, what do I get from the for each in that case? I get always a key value pair, right? It's an entry. So, and this entry now has to make the check. Check the numbers against the anagram. So if there are two G's, continue. Okay, what do we get as an error? We get a string can't be assigned to the parameters void string int. Ah, cool, I get both. I get the entry directly inside of that function. So what we get is the key and the number, or amount, better said. Cool. And now we have to understand that anagram. And now I could iterate over the anagram, or would it make sense to also put the anagram into a map and take then the both maps and just check every single key? What would you say? Or would that be too much? We can have here the print. I think that we can remove that for now. That check is here, so cool. And now we could do something like for each char var anagram char in anagram reference. Yes. So this is a string. I will do that for now. I think I'm happy. If we, instead of splitting that, just that we create this anagram and do the same for that, and then we just check the different keys. I think that's the easiest way. So map, we have a string against an integer, anagram. Can really hear your clap on the head today. So anagram map. So this anagram map is just the same thing that we did here, more or less, for the anagram. Could be done here. We take the chars from the anagram reference, and I really have to check if there is a better option to create these maps, because I can't imagine that this needs to be that complicated. Okay, so now we have that. The result list stays the same. We still need that. But the benefit is now we have exactly the amount of the anagram chars that we need. And here we have the word map. We have the word reference split. Yep, can still use that. Do we? Yep, that is good. And here we can now just iterate over the anagram, I think. So if I take the anagram map now here and say for each, we have now every single, what do we have in the anagram? We have chars, right? So we get also the key and the value or amount. And now we have to, it's the wrong way around, right? We want to check that against the word map to for each, and every single char here inside is coming back and doing something for us. And what we want to do is not only the char, which is not a char, it's a key. Is it? C1 true. Oh, you're right. Why is that the case again? So I think one thing would be why GAL. Okay, let's take a look. Let's get that string again and take another look. I thought the keys are unique, but maybe that is also the case. So the update is maybe overriding it again. But why it would say it if absent is 1. Let's take another look here. So Scores, put if absent, okay, I understand. So for each, and if I want to create an... And each key has exactly one value associated with it. So the last chord should contain 2t. Yeah, true. Yeah, so the t is getting overwritten by 1. Okay, so it is generally not allowed to modify the map. Okay, that makes sense. Add or remove keys. Yep, don't want to do that. While an operation is being performed on the map, for example, in function call during for each or put if absent call, modify the map while iterating the keys or value may also break the iteration. Okay, fine. So, but how do I make the count here? That is weird. Where's the update that I use? That is add all, add uptrace, contains, put if absent. Okay, update. Returns the new value of the key. So key update has a value that is the integer. And it's update. Maybe I made there the mistake. So we have the update. That is the key, and maybe this is not just... No, it is the function update. It looks good. Let's see. Updates the value provided by key. Good. So we update G, for example, or in that case, T. So then we return the new value of the key. If the key is present, invoke update with the current value and stores the new value in the map. Invokes update with the current value and stores the new value in the map. So I would expect that we get now with that update function, we get the value inside, that is the old one, and we update it with the update one. Okay. Did I return everything correctly? Yeah, it's immediately returned. And what? If the key is not present and if absent is provided, calls if absent and adds the key with the returned value to the map. It's an error if the key is not present and if absent is not provided. Okay, it should fail if it's not the case. That is weird. Let's see if I find something. Dart map update. It returns the value. Update existing value is value and if else value. Okay. Yeah, could be. But still it would feel weird, or? What is now wrong? Yeah, sure. Silence. So, let's see. You're right. Wow, that is bad. So why is the T1 still? If this is the case and I print maybe the anagram too, anagram, just to see what we have as a reference. So tapper, so we have two P's, so that is fine. T-A-P-P-E-R. Hey! The famous ++ error. Okay, that was silly. Yeah, sure, but of course it makes also a lot of sense, right? Because it would jump over, it saves the one back into the map, and because it was the old one, nothing changed, and later it doesn't have the reference anymore. So the closure here is the problem. Fair enough. Good. So we get the stuff, we get go, everything is green. The only thing is we have to change our work here. Instead of using this, we have now to compare the old map, the word map with the anagram map. Hey, success. So word reference, the word map for each we want to go over every single one of them. So we have the key, and I hope we have the value of that key or amount. And what we want to do is inside of here, we want to check the anagram now against that word. So what we can do is we can just take the anagram dot, and I hope there is no comparator is for sorting, but I can just execute that with the key. And that could be wrong. Can't be assigned to types integer. Why is the anagram an integer? Anagram map, of course, yep. The anagram map key. So, and now I can make that a try catch, because if that is failing, the word, the letter is not containing, right? So we are maybe ready with that already. I don't just like the idea that we just fall on the ground, but for now I keep that just to see what happens. So we should fail here at least once. Go Tapper, no, still happy. Weird. Because I don't do anything, most likely. So anagram map key has an amount of numbers, I assume. So that should be an integer. And this has to be the same like amount. And if this is always true, then we have a fitting word, right? So if this is correct, we have is, no, wait, this not, because that has to go all over. And after that, we know that the word is actually an anagram. String find first t, I think so, yes. Anagram dot find first match as prefix, replace all starts with find first t or something. Why would I need the first of something? I can use the contains method. Now I know that something is inside. I understand. What I can do is I can just say, forget what I said. Okay, I try. It's kind of difficult. So now if this is failing, we print the error, nothing happens. But if this word for each, we know now, okay, so where's my is word anagram? There. So this is part of that. So before we come into that for each loop, we do that. If we ever catch this, no. Slowly. So we have a word map. We go over that, over our anagram. We check the keys. If the word, so the letter is there with, for example, G, then we check the G in the anagram. And then we double check the amount, because we get back with that the amount. And if this is working, everything is fine. If we get an error, we throw. And what I thought is that I say now we check if the anagram is there. That this one is an anagram, or I can just add it, right? If all of these, okay, slowly. We have that. We have now for each. We get the keys, we get the amount, and now we want to understand that this one is an anagram. So this tells us that one of the letters is correct. It has the same value, right? So we have all of them, but whenever we fail, the anagram is not, the word is not an anagram, right? Because if the one letter is not inside, it's not possible. So is word anagram would be false, right? I would say. And with that, I try to take that up again, and let's see if you write no again. So don't do it for each, make a simple loop. Okay. What would be the benefit? I can do so. Yeah. So let's do it and make that not for each. Var, we have the key. Why should I make a normal loop? Well, that would anyway not work, but slowly. I have to understand what I'm doing. That don't help anyone. Okay, guys. We have the word map for each. We have the key. We can do a normal loop, but why? What I want to achieve? It's because of the because of the break. That is the issue. All right. So, can I break? No. Yeah, you're absolutely right. And this is a stream. Yep. Now it makes sense. But still, I think I have the problem that I cannot easily use the entry. I think so. Word map would not work. So with that, I really have to iterate over every single one of them. Yep. So what I need to do is then word map.keys. Yeah. All right, so that means var I, can I say something like word map.length? Yep, sure. So let's see. That means I is 0 and I is smaller than the word map.length, and we say we increase that. So now let's think about it. Still, we stick with that one, and we need the word map dot. How do I get the entry now? The map entries of this, can I just give the I inside? I don't think so, right? It works. But this needs to give me one element. This is not a list, it's a map, so it will not work. I have to do that, but via the keys. The keys of this iterable of strings. Yes, and now I have to use the I inside. I'm still not sure if I'm doing that correct. I have to really read up the isn't defined in the iterable string. I just want to have the first one get index or something. Wait, I'm doing too much again. We get the word map.length. So we have a map with multiple things inside. We go over the list, and word map is a map. So let's see if this is just returning the entry, but no, this will return most likely the amount. And if we do that, we can have the anagram. Anagram map, and would say the same, but most likely now I get the wrong because I need the key. So how do I get the key for that? Contains key. I get an iterable of keys. So I can make that and say element at and give the integer inside. This is now my key. And instead of this, I'm doing that. I think it's better. So good. Now we have now, and then word map C equals anagram map C. Yep, got that. Okay. So now we have the different keys. We have that. We have now the check. And now we want to, if this is true, we want to break. No, that is checking against every single word. If we are not able to find the words with the correct amount, then we are just breaking the loop, right? Because that word can't be, we are looping about the word map, but still. What happens if one of them is failing? Then we immediately want to break, right? So something like bool test equals true. And if test equals to that. And we have also to, is it test? I can just say something like if test, and then if test is ever wrong, then we make a break. We don't have to go further. And I think I can put that even to the beginning. So every single letter in the word gets checked. If one of the letters is not correct, then we fail, because then we don't have an anagram here. But if we have an anagram, so test is valid, then we can add the word actually. And the word would be, in that case, the word map length. In that case, this word that we are working with. So what I have to do is the word map, what is the name? The result list, I think. Dot add, and now we can add the word. And the word is getting here. Cool. So what could be happening? Well, one more thing. I could imagine that this one is failing somewhere, because as I said, we have to try catch that, I think. Because when the key is not inside of that, we really want to just throw and work further. And then we also want to break. I think, no, wrong. We just want to set test to false. Is it not nearly the same that I had before? Or do we actually don't want to do that at all? Cool, can do so. And here we call it check for break, or no, just break. No, wrong. You're absolutely right, yeah. Okay, but still we want to have that. We want to break. Now we have the benefit of the performance thing. We only check against the words that are existent and have the possibility at all, because we created a map out of it. And now we add that to our result list. And with that, we can remove all that for each stuff. I think we can also remove nearly everything of that stuff here. Yep. Good. And also, I think even this stuff is not necessary anymore. And this test here would be more the faults of that. Okay, let's test first if something is happening. So 5 tests are wrong, good. So now everything is true, because that thing here is never checked against the if anagram, right? So the word test is false, test is broken. So here we check against the words. If they are ever false, we are jumping inside here. So we have to write something like if test, then we do this, and we can make that wrong and give that a better name, else I'm driving crazy. So test, what is that? It is an anagram. I'm still confused. It's still, I can just use that one or not? But I'm still confused. Can I not just use that Boolean up here instead of the is test stuff? So if I bring all that back for now, one. I think we don't need that anymore. And this for char stuff, I don't need that anymore. And this anagram stuff is most likely that what you want, right? So if I put that up, we have the Boolean test, good. So is anagram, yeah, I use the is word anagram, and I do the actual is false, that is true. Go down here. Cool. So now we have still is word anagram false. Is word anagram. But this is the negative part of that. So is word not anagram, or if it's false, then it is an anagram. Yeah, I think that makes sense. So now we set that to true. Is word not anagram? Then we add it. No, it is exactly the opposite of that. And this can be gone. I think this is the char uppercase. And this for loop can be gone too. Voila. So, that was a ride. Let's see where we get. Still 7 tests failing. Okay, so we get more tests failed now. Way too complicated. Still have to clean up. I just want to bring it to a state where I can read again. So we have the anagram for child word reference. So we create the word reference. That is fine. I think that is okay. Is word not anagram? Jeez. So is word anagram? If is word anagram, break. Why should we break if it is an anagram? That makes no sense. It's just... Set is word anagram false. Then if the variable is after the loop still negative, you don't have to add. Ah, yeah, true. Why I do this negatively? Because if is word anagram is true, which we set somewhere, I think, somewhere down here. Yep. Ah, no. We want to do the opposite. Okay, so we want to have is word anagram true. If this is true, which makes sense. And then if it is not an anagram, we want to, yeah, false. I think that makes more sense. So is word anagram? No. If it is, no, this one has to be true, false. So, no. Yeah, so is word anagram? No, then we break. After that, we set the word is anagram. That is always an anagram if these words are true. If something is failing here completely, then we set the is word anagram to false because it is not anymore. And now we add the whole thing to the list. Still failing, okay. We don't actually ever add to the list because most likely this here is never get set to true. For each word number, most likely the element here that is wrong. Get rid of the here? Ah, you mean of this if statement here? Just like that. Expected inlets. Now we have the Google again inside. Okay. So if is word anagram. So we print the keys. We have the word maps. Inside the loop. Why is Google actually one of them? They shouldn't be able to. Ah, because later they get set. Yeah, sure, I need to break that. And I need to break that as early as possible. So is word anagram break. and you say I don't need that here. What happens now? I remove all of them. Ugh, my head, what is wrong? So this is false. Becoming is word anagram break, so then we don't have to do anything anymore. But the problem is what is the problem actually? The end of the loop, not the beginning. So you think after that here I can just say if is word anagram, then we just break. No. Actual is last. Now we are coming to the problem that we have this again. So with different cases, we get eons and eons. Most likely in our map, I save currently all in small letters. If not, anagram. Yeah, if it is not, if is word anagram, not, right? No? Wait, one by one. So now let's try to fix some tests at first before I drive crazy. But I think that should be fine, or not? If it is an anagram, I add, else we break. We try, we go to the loop. Yes, I think that's it. Or? No? Yeah, I think so. Okay. But we need the keys at least to uppercase, I think, because else we don't add them correctly. So these... Yeah, I'm 30 seconds behind. So that's always a problem at the moment. I don't know why, actually. I tried to improve that, but somehow the stream is always a bit behind, even though in YouTube it stands that I'm pretty on time. I have no delay. Don't know what happens. Yeah, the latency in Germany is very bad. Oh, I don't know why. Okay, so but back to our problem. So we want to make these ones in capital letters. So how can we actually do that? By creating this char that we get from the anagram, I just make these to uppercase. So no matter what comes in, I make them uppercase. I think that is the same solution like before. You can also make them to lowercase, should be fine. And we get some tests fixed. Yay! All right, not too bad. Well done, Stillnox. Well done. Okay, I don't... Ah, that was a nightmare. And still, I'm not happy with it. There is so much stuff that couldn't be wrong. So let's fix the last two tests and then let's have some refactor session if I can clean that up. No. Both are failing. Okay, so we expected an empty list, but we get all of them, by which that should be the first one of them. So we come in with banana, and we should get an empty list. Seriously? Ah, the word itself is not allowed. Ah, that is amazing. So the word itself is not allowed. Okay. Of course, an anagram of itself would be really stupid. Okay, now we count everything, which is perfectly fine, but we only add the word if, no, wait, if the word is an anagram and the word is unequal the anagram itself, and both, of course, to lowercase or uppercase. So to uppercase and here also to uppercase. So let's see what's going on. Yeah. Okay, at least that is working. Cool. So, but now still I'm thinking this is a bit way too complicated or not. Is there no option of making it easier? Can't imagine that. So we have this with that number plus plus, and I think that is fine with that map. That just make it a bit more readable. Same for that. So now we have here the if word length and anagram length, and we have to check the word in any case. So that is true. But could I? Yeah, because we don't want to run into. What I could do instead of doing this, I could say if this is unequal, I can just break that word, right? Because, and if I do it instead of a for each, I can just make a for loop again. I think that makes sense. So we say this is, safe, and this is unequal. And if I would say here instead of for each, I just make a for loop again, which should be pretty easy. So for var word in comparison list, we do exactly this. Yep, and remove that, and now we can just override that. Perfect. Do we get an error? Yeah. Okay, yeah. So, and this can be a gun too. So now we have the for loop, and with that we can have this unequal with the break. That solves one issue, but brings some more. Cool. So let's see if the tests are still running. Sure, you can filter in Dart. What should I filter? The comparison list. If the word length is unequal, yeah, that is true. That should be makes way more sense. It's easier. True. So what I can do is I just make that with the fluid design. I can just say where, give the test inside, so we get a word. And if the word is and if the word dot length is unequal the anagram dot length, and of course not unequal, it is equal. So should do the same thing. What? Shorter than expected at location. Okay. Yeah, I can also do the same. Yeah, that's true. But still, why do we return again nothing? That's not fair. So we want to have in that list only words that have the same length as the anagram. And word is just here, this one. Then we for each. That should do the trick. I have still this if thingy majingy inside, so that is the problem. Cool. So. Cool. Lucky me. Okay, and the same thing for the word uppercase and this one, you're right. I can also bring that up. I think it looks much better. I will write another where clause here and give it inside. Yeah, I think that's fine. Yep, cool. And if in line 19, yep, you're right. Thank you. So we cleaned that up. That is good. So that is already way better. That creation of the map. I'm still not sure if this is the only way how you can create a map in Dart. I really have to take another look into it. It would be great if I can just take the anagram reference and create a map out of the list, because it is a list, so I thought it should be easy to create that, to map or something. A bit sad that this is not a case. So let's see what the Dart reference says us. Dart API list to map. Map from iterable, perfect. That could be exactly what I want. The only problem that I see here is that it could be that the item to string, can I make that uppercase? Yeah, I can, I think. So I think that is something that I should do. The example below creates a new map from list. The keys map are list values converted to strings and the values of the map in the square. Okay, so what I can do is, I take that map, instead of creating it up here, I can say from, no? It's a constructor, sorry. So from iterable. Now I give the list inside, that should be the anagram reference. What a bad name, actually. Anagram char list, something like that. And now, can I do something that from iterable? Yeah, I can give the list and I can set what the keys should be, because I need to make them uppercase, right? So I can take that, can say key, give the item side, item to uppercase. What is item in that case? String list key is item, item to string. Item is an integer in this case. String to int and what is that key here? That key is k, so the element is anyway the value that is inside. It's not really helpful. I think that is not possible here, because we have to make these keys uppercase. Or could we collect the keys and then after that make them uppercase? Nah, I think that is not worth the effort. So let's create a map like that, and then where's on that something like, no. Okay, so we uppercase, we have this wherever, we have this filters that for each works. The word reference is fine that we split that, especially if we do that. I think that map creation, yeah, should be up there, it's okay. We have that is word anagram, no. Then we have this for here, for every char, that is fine. This should be also fine with the break, good. Can we improve something? We could add the keys here, but I think that is not a good idea. With the try catch, yeah. I still think if something is wrong here, we can just jump over. We go now to the whole anagram and work over it. Yeah, but that is fine, I think. Good. And at the end, we add the results, we return the list, and I think that should be it. Phew. So let's remove that and push the whole thing. Excersim, submit lib and anagram. And then take a look what other people think. I can get rid of line 37. Okay, I think you mean 36 in that case, or then it is false anyway. Ah yeah, you're right. Ah, you're absolutely right. I cannot even get rid of the try catch because it's anyway false. Ah, I still have to try catch it. But because else it is not there, so then we fall without any parachute. But I think that should do it. Good. And if is anagram then we break. If is word anagram, then we add it, else we go back and start all over. Cool. So let's see what other people have done in that area. Really curious now. So we close all of that, we can close that, and let's have a look. So that is our solution. Go back here. Okay, and I want really to take a look into the community, what they have solved here. Okay, and I think that is the easiest solution. They split, sort, and join. Line 31. Let's have a look. Just that for loop could be simplified. I could make a for each and then get the keys, and that would be like we had before, but then we can't break it. We want to break it. So I++, where do you see that possibility? Keys element at I. I could try to make that with the word map in part, but I don't think that will work because word map is an entry. So if I have here an entry and say in word map, it will not work, unfortunately. Is used for loop must implement iterable. Yeah. For var key. Does this work? Never seen that nomenclature. So like that? No. Thought so. Var key in wordmap.keys. Yeah, sure. In the keys. Cool. And then we can use the key and we don't need that. Yeah, that looks pretty good. Yeah, sure. I just needed the keys. Okay. So that solved already a lot of my problems, I think, tonight. Good. Let's submit that. And now let's take another look at this solution. That's pretty interesting that someone solved it like that. So we have the options with a sort and join. Yeah, the problem is I don't actually know what happens. They sort and join. To lowercase split, sort, join. Okay, they sort the letters so that have you. That is smart. And then the same thing for the second one. And where is options coming from? Yeah, that is this one. And they use the filter of the string. S, split, sort, join. Wow, wacky. Interesting. Yeah, this is the looping possibility. I think that looks pretty much like I tried to start with. So looping over everything and looping again. Yeah, this one is the same, I think. Yeah, but I'm pretty happy with the solution with the map. Well done. Thank you so much for the idea of that. That is, of course, way better. I think I can live with that very good. Of the if afterwards, I break the loop and I can get rid of afterwards. So I break this one, but I only break the loop of the different keys. So I don't break the loop over here, up here, right? That one, so that for each, but I think you know that, because that is, you can also get rid of the if afterwards. Of this one, are you sure? I can't really imagine that this will work easily, because that would lead to a problem, or not? If we have here just... no worries, that's alright. But I think, yeah, it's a very easy and readable solution here, and I'm very happy with it, so I keep that for now. And I think with all that, we got a solution for yesterday, very good. And with all that, I think that's it for today. Thank you so much for joining me today, and I hope we see you at the next time if I'm making another training session, or maybe we are talking a bit more about Flutter, or yeah, I'm starting another track. So thank you very much for joining me, and till the next time, guys. See ya! I'm drinking my last.